All right, today we're going to be looking at section 5.2, part 2, where we actually use the unit circle in order to evaluate some problems. So first, starting off, we're finding values of trig expressions. We're going to use the unit circle, and we're going to use that chart that we constructed also. All right, so a couple things first. Here's the unit circle. I just have a little bit smaller version of this so I can fit it up on there. So that's what we're talking about, the unit circle. The other one is this chart that you completed. So this right here will be very helpful in us for finding values, and we'll talk both ways on how to find these values. So let's look at the first one right here. As long as it's on the unit circle, I can evaluate this function. So number one says the sine of 45 times the cosine of 180. So the first thing I'm going to do is find the sine of 45 degrees. So let's look at the unit circle approach first. All right, here's 45 degrees. Remember, on the unit circle, the x-coordinate stands for cosine and the y-coordinate stands for sine. So the sine of 45 will be this y value, which is the square root of 2 over 2. Another way we can do that is look at our chart right here. We've got 45 degrees, we have sine, and for that we got the square root of 2 over 2. So same value for both of these functions right here. So on this first part, the sine of 45 is just the square root of 2 over 2. Now, since these two things are side by side, this just means I'm going to take these two things and multiply. So the next thing I need to find is the cosine of 180. So unit circle approach, here's 180. Cosine is the x variable, so the x variable here is -1. Or I can use my chart, and we've got cosine 180. You should have also gotten out -1. So for both of those values, we get out -1. Cosine of 180 using the unit circle and using the chart. So here, all I'm doing is multiplying fractions. To multiply fractions, all you do is multiply straight across. I'm going to stick a 1 up under this denominator and multiply straight across. The square root of 2 times -1 is negative square root of 2. And 2 times 1 just gives me 2. So the value of this is negative square root of 2 over 2. All right, now, let's look at number 2. On number 2, we've got tangent of pi over 4 minus the sine of 3 pi over 2. Now, since this is tangent, it's going to be easier for me to use my chart right here. All right, so pi over 4, same thing as 45, and I want to find tangent. So the tangent of 45 is 1. So the value of this is 1. So this is 1 minus, and I'm going to find the sine of 3 pi over 2. 3 pi over 2 is right here. Here's 270. Here's 3 pi over 2. Let me scoot it over so you can see it. So we've got 3 pi over 2, which is the same thing as 270. I want the sine. The sine of that is -1. So I've got 1 minus -1. Two negatives make a positive, so 1 plus 1. The value of this one is going to give me out the number 2. All right, then we get to number 3. Number 3, secant of pi over 4 squared. Since this is secant, the best thing to do is for me to use my chart once again. Now, the chart's going to be the easiest for you. So I'm going to go to pi over 4 and find secant. So here's pi over 4. Secant is right here, so that would give me out the square root of 2. So the secant of pi over 4 would be the square root of 2, and that gets squared. So this is the square root of 2 squared. Now plus, now I'm going to find the cosecant of pi over 2. Pi over 2, same thing as 90 degrees. Cosecant, this right here value gives me 1. So this is plus 1. Now if we square a square root, the square root goes away. So the square root of 2 squared, square root and square away, just gives me with 2. So this is just 2 plus 1. So the value on this problem just gives me the number 3. All right, going to number 4. Number 4 is the sine of 45 times the cosine of 45. So both of these are 45 degrees. So here's 45. The sine of 45 is the square root of 2 over 2. The cosine of 45 is the same thing, square root of 2 over 2. So I'm basically taking these two things and multiplying them together. So this is the square root of 2 over 2 times the square root of 2 over 2. To multiply fractions, like we said before, we just multiply straight across right here. The square root of 2 times the square root of 2 is the square root of 4, which is just 2. And then 2 times 2 gives me 4. So this is 2 over 4, and 2 over 4 simplifies into 1/2. So 1/2 is my answer for that one. All right, the next one, number 5. 2 sine pi over 3 minus 3 tangent pi over 6. Going back to my chart again. Now this 2 comes out in front, so 2 is going to get multiplied by whatever I find to be the sine of pi over 3. All right, so here's pi over 3. The sine of pi over 3 is the square root of 3 over 2. Remember that 2 is out in front. So 2 times the square root of 3 over 2 minus 3 times the tangent of pi over 6. I'm going to go to pi over 6 and find tangent. So here's pi over 6, here's tangent, and I get this out, square root of 3 over 3. Don't forget the 3's in front. All right, now, order of operations, I have to multiply these two and then subtract. So if I look at this first one, first thing to multiply, you could go straight across, or you could see if you could simplify. This 2 here crosses out with this 2 here. So that just gives me the square root of 3. Over here, 3 over 1, 3's in the top, 3's in the bottom, so these reduce, and then multiply straight across. So right here, I'm just left with negative square root of 3. So I've got square root of 3 minus the square root of 3, same thing minus itself, gives me out 0. All right, let's look at this last one right here. We got cosecant of pi over 2 first. So here's pi over 2, here's cosecant, we get out 1. So that value for the first one is just 1. Plus, next thing I want to find is the cotangent of pi over 2. Here's pi over 2, and here's cotangent way down here at the bottom, which gives me out 0. So this is just 1 plus 0. Well, 1 plus 0 just gives me 1. That's how we use our chart. Or, remember, we could go back to this unit circle in order to evaluate trig expressions. All right, let's look at the second thing right here. The second thing is finding values of trig expressions. So to find values of trig expressions, let's see if I can zoom in here to get this a little bit better. All right, finding values of trig expressions, and these are with negative angles. So the first thing, if I have a negative angle, I'm going to change my negative angles to positive angles. How do I do that? I just add or subtract 360 degrees. Now, if it's not in degrees, we need to go back and change it in degrees by multiplying by 180 over pi. All right, so let's look at this first one first. We've got the sine of negative 90. Well, this is a negative angle. So first thing I'm going to do is take negative 90 and add 360. That's the same thing as 270. So this right here is the same thing as the sine of 270 degrees. All right, minus the cosine of negative 90. If I take negative 90 and add 360 again, I'm going to get the same thing out, 270. So this is the cosine of 270 as well. Now, since 270 is on my unit circle, and it's also on my chart, now from this point forward, we can do just like we did in those last 6 problems, where we evaluate. All right, so here we go. Here's sine. 270 is way over here, so I'm going to slide out over here. Here's 270, so the sine of 270 is negative 1. The cosine of 270 is 0 right here. So the sine of 270 is negative 1 minus the cosine of 270 is 0. Negative 1 minus 0, my answer here comes out to be negative 1. All right, next one we have is radians. So to change radians to degrees, first thing I need to do is take negative 4 pi over 3 and multiply it by 180 over pi. So let's look at this real quick. Just looking at these radians right here. Negative 4 pi over 3 is going to get multiplied by 180 over pi. These pi's are going to go away. So basically I'm taking this fraction part and just multiplying by 180. So negative 4 over 3 gets multiplied by 180, and that's negative 240 degrees. So I'm going to rewrite this as the cosine of negative 240. And I'm going to do the same thing for negative 2 pi over 3. So negative 2 pi over 3 is going to get multiplied by 180 over pi. Pi's go away. So I'm basically taking negative 2/3 and multiplying by 180. So negative 2/3 gets multiplied by 180, and that gives me out negative 120. So this is the same thing as the sine of negative 120. All right, now since we don't like negative angles, I'm going to take these negative angles and add 360 to get it to be a positive angle. So the first thing I'm going to start with is negative 240. So negative 240 plus 360, that's the same thing as 120. Now I'm going to take negative 120 and add 360, and that's the same thing as 240. So this one's changing over to positive 120, and this one's changing over to positive 240. So this is what I've got. The cosine of 120 times the sine of 240. Now everything's positive angles. They're all on my unit circle, so I can use my chart to evaluate from here. All right, so first thing, let's start with the cosine of 120. So here's 120, here's cosine, and I get out negative 1/2. So negative 1/2 gets multiplied by the sine of 240. So here's sine 240 is all over here, which gives me out negative square root of 3 over 2. So this is negative square root of 3 over 2. To multiply two fractions, I just multiply straight across. Now, first thing I notice is, can I reduce? I don't have the same number here or here. If they're both in the bottom, I can't reduce. I just have to go straight across. A negative times a negative is a positive. 1 times the square root of 3 is just the square root of 3. And then the bottom, 2 times 2 gives me 4. So this answer is negative square root of 3 over 4. All right, next we're in terms of degrees, but we have negative angles. So the first thing I'm going to do is take both of these negative angles and change them over into positive. So negative 315 plus 360, that changes over to 45. And negative 45 plus 360 is going to change over to 315. So they're basically just switching here. So this is the tangent of 45 plus the cotangent of 315. Now use my unit circle to evaluate here. So first thing is the tangent of 45. 45 tangent gives me out 1. And then I've got plus the cotangent of 315. Now cotangent is all the way over here at the bottom. 315 is all the way over here, which gives me out negative 1. So I've got 1 plus negative 1, well 1 plus negative 1 gives me out 0. All right, let's look at this next one. We've got negative angles, so let's deal with those two angles first. Now, that actually be the same angle. So negative 30 plus 360 is 330. So both of these change to 330. So this is the cosecant of 330 times the sine of 330. Now I'm multiplying here. So first thing, I want cosecant and sine of 330. So cosecant's here. Let's do this one first. Cosecant of 330 all the way over here is negative 2. So this is negative 2 times, now I want the sine of 330. Sine's this top one. All the way over here, 330 gives me negative 1/2. Now to multiply fractions, I multiply straight across. Now first thing, reduce. See a 2 in the top and the 2 in the bottom? Well, those two 2's go away. So when I multiply straight across, I got negative 1 times negative 1, which is 1. On the bottom, 1 times 1 is still 1. So my answer here just comes out to be positive 1. All right, next thing we got secant of negative pi. Now, I could change this to radians by multiplying by 180 over pi, or if you notice on your chart right here, pi is on your chart. Pi is the same thing as 180 right here. So if pi is 180, then negative pi is negative 180. So this is the secant of negative 180. All right, minus the cosecant. Negative pi over 2. Now, negative pi over 2 is not on here, but pi over 2 is. Pi over 2 is 90. So instead of this being 90, this is just going to be negative 90. All right, so next thing, let's deal with those negative angles here. So I'm going to take negative 180, add 360. That gives me out positive 180. Then I'm going to take negative 90 and add 360, and that gives me out 270. So 180 is the first positive one, and 270 is the second one. So this is the secant of 180 minus the cosecant of 270. Now I go to my chart in order to evaluate here. So here's secant. 180 is right here, and that gives me out negative 1. So we got negative 1 minus. Now I want cosecant of 270. Cosecant's right here, 270 way over here, which gives me out negative 1. So negative 1. Minus a negative gives me a positive. Negative 1 plus 1, answer here comes out to be 0. All right, let's look at this last one right here. We got negative 210 plus 360. This is 150 right here. And then I've got negative 120 plus 360. Remember, we don't like negative angles, so let's get rid of them. So that's the same thing as 240. So let's rewrite these trig functions right here. Cotangent of 150 plus the tangent of 240. Since this is on my unit circle, let's go and evaluate it. So 150, here's 150. I'm finding the cotangent, which is right here, negative square root of 3. So the cotangent of 150 is negative square root of 3. Plus the tangent of 240. Now 240 is over here. The tangent one is this one. See, I'm looking at the tangent, and 240, that's positive square root of 3. All right, same thing. One's positive, one's negative, so when I add them together, I get out 0. So the basic idea here is if you have negative angles, convert them over to positive angles by adding 360. Then it becomes a problem just like we did earlier. All right, last problems right here. What happens if something is not on the unit circle? Well, if it's not on the unit circle, we got to go back and use SOHCAHTOA. So remember, sine was opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and these are my reciprocal functions right here. Cosecant's reciprocal is sine, so it's flipped upside down, hypotenuse over opposite. Secant's reciprocal is cosine, so it's flipped upside down, hypotenuse over adjacent. And cotangent's reciprocal is tangent, so it's flipped upside down, adjacent over opposite. All right, each of these come from one of our quadrants, so we're going to draw those reference triangles like we've drawn before. So on this first one, we got the point 3, 6. Well, 3, 6, everything's positive, so this would be a triangle in the first quadrant. So it looks like this. All right, my x value is 3, so this is my x-axis. I'm going to put 3 on my x-axis. My y value is 6, so this is my y value right here, 6. So I need to find this hypotenuse first. To find my hypotenuse, we're going to do the Pythagorean theorem. A squared plus b squared equals c squared. So a squared plus b squared equals c squared. These are my two legs, so this is 3 squared plus 6 squared equals c squared. 3 squared is 9, 6 squared is 36, so that equals c squared. So 9 plus 36 gives me out 45. So 45 equals c squared, so c is the square root of 45. Now, 45 is 9 times 5. So remember, we got to break this thing down. So this is the same thing as 3 on the square root of 5. So I'm going to come up here in my triangle and write 3 on the square root of 5. Now, since I'm given that point, I can find all 6 trig functions based off of this triangle. So let's just look at a couple of them right here. So first, let's just find sine of alpha. Remember, sine was opposite over hypotenuse. So this is my angle right here. So if I want opposite, that's 6 over hypotenuse 3 on the square root of 5. So this is 6 over 3 on the square root of 5. All right, first thing I'm going to do is take this 6 and 3 and reduce. So 3 goes into 6 2 times. So this is basically 2 over the square root of 5. Next thing I have to do, I cannot have a root in the denominator. So I need to rationalize this denominator by multiplying by whatever's in the bottom, which is the square root of 5. So here I've got 2 on the square root of 5. And then the square root of 5 times itself is just plain old 5. So here's my solution for just plain old sine. All right, now let's look at one more. So let's take this and let's find tangent. So the tangent of alpha. Tangent, remember, is opposite over adjacent. So this is opposite, this is adjacent. So this is just 6 over 3. 6 over 3 just reduces to the number 2. But we could find all 6 of these if we needed to. But let's keep going. All right, so let's look at number 14. Number 14, x is negative, y is positive. So negative positive is going to land in the second quadrant. So we're going to draw a triangle out in the second quadrant. All right, my x is negative 3, and that should make sense because I'm going to the left. So that's negative 3. My y value is going up, so that's positive 4. So to find my missing side, my hypotenuse, I've got to do the Pythagorean theorem. So here we go. A squared plus b squared equals c squared. Doesn't matter which one of these are a and b. I'm just going to let negative 3 be a. Negative 3 squared plus 4 squared equals c squared. Negative 3 squared is 9. 4 squared is 16. That equals c squared. So add them together. 25 equals c squared. So the square root of 25 gives me 5. So my missing side, which is my hypotenuse on this triangle, is 5. Now let's find some different trig functions. Let's go with cosine. So cosine alpha. All right, here's my reference angle right here. Here it's attached to the x-axis. So cosine is adjacent over hypotenuse. So here's adjacent, close to it. Here's hypotenuse, 5. So right here, remember we said this was adjacent over hypotenuse. So this will be negative 3 over 5. And I cannot simplify that. All right, next thing, let's go with another problem. And on this one, let's find cotangent of alpha. Cotangent is adjacent over opposite. So here's adjacent, but here's opposite all the way over here. So this is adjacent over opposite. My adjacent side is negative 3. My opposite side is 4. So this is negative 3/4. I don't have a root and I can't simplify. So that stays my solution. All right, let's move on to the next one, number 15, so we can see one coming from all different quadrants here. All right, on number 15, everything's negative. So my x is negative and my y is negative. So this one is going to land in the third quadrant. Remember, it's always push to your x-axis right here. All right, x is negative 1, y is negative 2. I've got to do the Pythagorean theorem to find this missing side right here. So going with a squared plus b squared equals c squared. A is negative 1, b is negative 2. You could switch those two if you wanted to. Negative 1 squared is 1, negative 2 squared is 4. So 4 plus 1 gives me 5. So c is the square root of that. So it's the square root of 5, and I cannot break that down right there. So this is the square root of 5. All right, let's find some different trig functions with that. So on this one, let's go with cosecant first. All right, going back up here to cosecant. Cosecant is hypotenuse over opposite. So I'll write that down, hypotenuse over opposite. All right, so here's my reference angle right here. Hypotenuse is what I found, the square root of 5. Opposite side is sitting right here at negative 2. So this is the square root of 5 over negative 2. Right here, we always want to stick our negative sign up top. So this is negative square root of 5 over 2. I don't need to rationalize because the root's in the top. All right, let's look at another one here. So on this one, let's go back and find cosine, because this is going to make me have to rationalize here. All right, going with cosine. Cosine is adjacent over hypotenuse. Looking up here, SOHCAHTOA. So right here, adjacent is negative 1. Hypotenuse is the square root of 5. So this is negative 1 over the square root of 5. Now, I notice I have a root in the denominator. So I need to rationalize this denominator by multiplying by whatever's in the bottom. So I'm multiplying top and bottom by the square root of 5. All right, so I've got negative 1 times the square root of 5, which is negative square root of 5. Square root of 5 times the square root of 5 is the square root of 25, which is just 5. Remember we talked about whenever we multiply two square roots of the same thing, it's basically whatever's up under there is going to come out as your denominator. All right, last problem right here. I'm going to my last quadrant, positive, negative, positive, negative. Now I'm landing in the fourth quadrant right here. My x value, remember my coordinates x, y, so my x is 8, so that's going on my x-axis. My y value is negative 15. That should make sense because I'm going down. Pythagorean theorem is going to get me my missing side right here. So a squared plus b squared equals c squared. So I got 8 squared plus negative 15 squared equals c squared. 8 squared is 54. No, not 54, 64. So I've got negative 15 squared. That's going to give me 225. So 64 plus 225 equals c squared. I'm going to take 225 and add 64, and that's going to be 289 equals c squared. Now, if I take the square root of that, the square root of 289 actually comes out to be 17. So this right here is called a Pythagorean triple because I didn't have anything left over. It was a perfect root here. All right, let's find some functions based off of our trick. So we hadn't found secant yet, so let's go with secant. So secant of alpha. Secant is hypotenuse over adjacent. All right, hypotenuse is here. Remember, this is my reference angle. Adjacent is here, so that's 17 over 8. I can't simplify that, so it's just going to stay my problem. All right, next thing, let's go back and let's find tangent. So if I want to find tangent of alpha, tangent up here is opposite over adjacent. Here's opposite, here's adjacent. So that's negative 15 over 8. I can't simplify that, so it just stays. So if it's not a point on your unit circle, like that little unit circle that I showed you before, like this, if it's not a point on your unit circle, all you have to do is draw it out, put it in a reference triangle, find your hypotenuse, and then find the trig functions that's listed. So this is how we do stuff using our unit circle.